Hello everyone, welcome back to my YouTube channel. This is Mr. Sen Wasapi and I will be explaining transformers in this video. So before we continue, do not forget to like and subscribe to this channel. Alright, let's begin. So on the left hand side of the screen you can see an image, this one here. This image shows a transformer. I know most of us have come across such a device in our day-to-day lives, but for those that haven't, this is one of the tutorials that will show you how a transformer really looks. A transformer is found in several devices. Could mention a few such as fans. You'd find them on charger heads in most cases, and other related devices. Okay, so to start with, let's dive into the basic definition of a transformer. Okay, so in basic understanding, we could say a transformer is a device used to vary. The word vary simply means to increase or decrease the voltage of an AC supply. So a transformer will always vary the voltage of an AC supply. AC stands for alternating current. So the amount of voltage that is received by the appliance will either increase or decrease depending on the load that is present. So be mindful that a transformer is simply a device used to vary the voltage of an AC supply, and as we just said, to increase or decrease the voltage of an AC supply. Now with this in mind, you can quickly look at the components that are present on a transformer. The first component, we can talk about the primary coil. Other than the primary coil, we also have what is known as the secondary coil. And lastly, what we have is called a soft iron core. These are the three main components of a transformer: the primary core, secondary core, and finally the soft iron core. Alright, thanks for understanding. So, if you look at the basic structure of a transformer, we can use this simple illustration. This is what we call the soft iron core, and this is the load. The load could be the bulb or whatever appliance it is. And then this is the AC supply. This is the primary coil. These are the turns. And this is the secondary coil. I know at first glance most of you won't get it, but with a little bit of some practice you get a hang of it. So the AC is supplied at this point. That is where you find the primary coil. Then you have the soft iron core, the load, and the secondary coil. Now that we know the structure, we can quickly look at the working principle of a transformer. So this working principle of a transformer is simply one of the questions that are phrased by the ECZ. So be mindful of this. When it comes to the working principle of a transformer, how it goes is in this manner. Firstly, an alternating EMF, which is simply just the voltage, is supplied to the primary coil. Now, this supplied EMF is the one that allows an alternating current to flow in the primary coil, and this produces a changing magnetic field within the primary coil. Now, be mindful that a magnetic field, if this is a magnetic field is simply just a space or the region around the magnet that will cause other materials that are surrounding the magnet to experience the force of attraction or repulsion. So that's a magnetic field, a region around a magnet or a material that allows other objects to experience the magnetic force, which could either be of attraction or repulsion. So be mindful, after the EMF is supplied to the primary coil, an alternating current to flow in that same primary coil, which will produce a changing magnetic field within the primary coil. Then secondly, the changing magnetic field is linked to the secondary coil through the soft iron core. And lastly, the changing magnetic field cuts the secondary coil, creating an induced EMF or current in the secondary coil. Hence, the appliance, or let's say the bulb, will light up. And that is simply the working principle of a transformer in a nutshell. Like I said, at first glance, you might not get it right, but remember, with a bit of practice and more studying, you will understand the working principle of a transformer. This is simply just a summary of the working principle of a transformer. So remember to go through it and understand it and try to practice it. Now, there are some pointers you have to know. Pointers that involve the soft iron core. Now, questions might come or be phrased to say, give a reason why a soft iron core is used instead of other related materials like copper or aluminium. Now, there are several examples or reasons to why we use soft iron core. The first reason is that it's literally a soft magnetic material. The other point is that it loses less energy. So loses less energy. The third point is that it's easily magnetized and demagnetized. And the last point is that it has the ability to concentrate the magnetic field lines. So be mindful of these 4 important points. Remember to study them and you will understand them. So these are the 4 main reasons why we use a soft iron core. But the most common one is that it loses less energy. Alright. So now that we understand that, other questions can also be phrased where they would say, why is it that alternating current is used rather than direct current? Remember, AC stands for alternating current, and DC stands for direct current. Such funny questions are brought in the ECZ standard questions where they would say, what does AC or DC stand for? And these are no-brainer questions. So remember, AC is alternating while DC is direct. So now, the reason why we use alternating current is simply because the alternating current is the only one that can vary the voltage supplied, while direct current cannot. Because if you look at the direct current, the current that is produced cannot really is literally constant, and what we need is something that can change. If you look at an alternating current curve, you have what we call a sinusoidal wave. So for alternating current, the voltage can vary. It can increase or decrease. But if you look at the direct current, if the current is just positive, it just be like that. If it's negative, it just be direct. It will be constant. But for alternating current, the current will be alternating. Positive, negative, just like that. So be mindful about that. Now, with what has been said, we also need to know the types of transformers that we have. Now, we have what we call a step-up transformer. Now, a step-up transformer is literally just one that increases the voltage of an AC supply, because if you step up, you're literally increasing the voltage supplied. So be mindful. Just like we were defining a transformer basically to be a device that varies the voltage of an AC supply. Be mindful. The vary is literally just to increase or decrease. So a step-up transformer is one that increases the voltage of an AC supply. Now, if you look at the structure, we literally have the same parts. We will have the AC supply, this side. We also have the primary core. Then we have the soft iron core here, soft iron core. Then we have the load. This is the load of the electrical appliance. Then we have the secondary coil. Alright, so this is the basic structure of the step-up transformer. Now, if you look at the structure, you'd find that in the primary core, there's quite a difference as compared to that of the secondary core. For instance, these turns that you have are few on the primary core as compared to the secondary core. So this will be understood with what we call the characteristics of a step-up transformer. So the first characteristic is that the step-up transformer literally just increases the voltage of an AC supply. Then the other thing is that it has more turns in the secondary core. As you can see, it has more turns in the secondary core. You have more turns there than the primary core. So we say it has more turns in the secondary core than the primary core. That's why we were saying the number of turns. Look, N represents the number of turns, just so you know. Then V represents the voltage. Then I represents the current. So this implies that the number of turns in the primary is less than the number of turns in the secondary, and the voltage in the primary is less than the voltage in the secondary. And the last characteristic is that the current in the primary is greater than the current in the secondary. So be mindful about that. So the number of turns in the primary core less than the number of turns in the secondary core. The voltage in the primary core less than the voltage in the secondary core. The current in the primary core greater than that in the secondary core. Alright, now that we understand what a step-up transformer is, we can also as well look at what we call a step-down transformer from the word stepping down. So we know that we're decreasing the voltage of an AC what supply. Remember, we use AC because AC is the only one that can vary voltage, it can alternate. So a step-down transformer is a transformer that literally decreases the voltage of an AC supply. If you look at the structure, if you look at the turns in the primary, we have more turns than the secondary. This structure is literally different from that of a step-up transformer. As a student, you should know how to draw the structure of either a step-up or step-down transformer. Be also able to label its parts, showing the primary core, the soft iron core, the load, as well as what secondary what core. Because at times examiners would phrase questions where they would say give a simple illustration of a step down or a step up transformer, and be mindful the difference mostly is just with the number of turns. And one thing you should know is that the number of turns will show you the amount of voltage present in each part. It will be the left or the right. So the left will represent the primary or the right represent the secondary. So be mindful about that. So if you have more turns in the primary, like in our case, the number of turns is directly proportional to the amount of voltage. So the number of turns in the primary is more than the secondary, which means that you have more voltage in the primary as compared to the what? Secondary here. So now that we understand this, let's look at the characteristics just like we did for the step-up transformer. So now, what are these characteristics of the step-down transformer? So from the word step down, it decreases the voltage of an AC what? Supply, and has less turns in the secondary. As you can see, it has less turns in the secondary as compared to the what? Primary what? Column. And other than that, we can also say in another way whereby you say that you have remember, n represents the number of what? Turns. So we'd say is not on the number of turns in the primary, is greater than the number of turns in the what? Secondary. And remember that V represents what? Voltage. So the amount of voltage in the primary is greater than that in the what? Secondary. And the amount of current in the primary is less than the amount of current in the what? Secondary. Remember, the amount of turns, the number of turns, will show you the amount of voltage present. Now that we know that, let us now look at what we call a turns ratio. Now, a turns ratio is a simple and straightforward. It's one of my favorite ratios that we have in science. Now, remember, the number of turns, like I said, is directly proportional to the what? The voltage. So the number of turns is directly proportional to the what? To the what? Voltage. So be mindful about it. Be mindful about it. So the number of turns is directly proportional to the what? The voltage. This implies that the number of turns in the secondary over the number of turns in the primary is equivalent to the amount of voltage in the secondary over the amount of voltage in the what? Primary. So this is simply the turns what? Ratio. So with this in mind, now that you know the turns ratio, the only thing that you need to know other than the turns ratio, which is NS over NP being equal to VS over what? VP. Other than the turns ratio, you also have to know what we call an ideal what? Transformer. An ideal transformer is simply just a transformer that is what? 100% efficient. So this is a transformer that is 100% what? Efficient, which means it has no energy what? Loss. So this means that the power input is equal to the power output. Now this means that what it implies that you have the formula IP over VP being equal to what? Beauty IS over what? VS. Yeah, forget about that. Yeah.